Okay, so Nazar, let's pick up from where we left off. So, we went through this story, and I do think it's interesting that we've taken a coal-fired generation plant that's getting retired, right? Historically, that's land that's questionable in terms of what's it going to be used for, and you guys have now turned it into really a quite large data center campus. So I think you were talking about you started off with a 2-megawatt.
2-megawatt facility.
Why don't we start with the 2-megawatt story and
yeah,
and
and
tell us how you.
Yeah, so the team, and a testament again to the team that's here. I've over the years thrown them a number of challenges where they look at me and they say, "We don't really understand what you're asking us to do, but we're going to go try to figure it out." And so this was one of them. Again, we build power plants. They thought they had done a tremendous amount of work, which they had, in figuring out how to build Bitcoin mining data centers, which they've done. And now we come back and we say, hey, great, that's good, but this is a completely different beast. Let's go figure this out as well. And that's what that 2-megawatt pilot project was really about. It was, kind of rolling up our sleeves. And at the time, what we went out to various folks and saying was, 2 megawatts isn't a lot. We get it. But the site's going to be hundreds of megawatts.
Yeah.
And we want to work with.
How big is the site? You say it's going to be hundreds of megawatts. What is it today?
We have signed up today. Today we've signed up 500 megawatts of gross capacity and 420 some odd megawatts of critical IT capacity at the site.
Yeah.
We are waiting for an approval on another 250 megawatts of gross capacity that should come, sometime in the middle of this year. And that will then kind of dictate the timing for that availability of power.
Yeah, and a quick thing that I think is interesting to put context for many people. That's why the generation plant was 700 megawatts, and now your plans are 500 going to 750 megawatts of consumption. So you're consuming as much as the generation plant,
and that's because that substation was sized at the 700 megawatt power plant plus a 10% margin, right? So the substation was about 770 megawatts of capacity.
So that was part of the magic of this site.
Correct. Yeah. Is that, again, that all of that high voltage equipment was just there.
Okay. So we jumped ahead in the story to get the big numbers, but again, 2 megawatts.
2 megawatts. And so we start rolling on that again, and that's more rolling up our sleeves, getting it done. We're working through that. We start to hear in the market, hey, people like these 15, 20 megawatt data halls, that could be interesting. And so we say, great, this 2 megawatts going along well. Let's step it up a little bit. And so we did a 16 megawatt building, which is CB1, 20 megawatts gross. And part of the calculus on that was all this stuff takes a lot of money.
Yeah.
Right. On average, we're spending $9 to $10 million a megawatt to build a building.
And that's core shell, core physical infrastructure, but that doesn't
electrical, mechanical.
But that's none of the IT, just to be clear.
No hardware.
No IT hardware.
No IT hardware, just kind of the data center.
So I take raw ground, I put up a building, it's got cooling, it's got power, and you're ready to roll racks in.
Exactly. Okay. And so, again, in rough numbers, right? If we're building 400 megawatts here at $10 million a pop, that's $4 billion.
Yeah.
Not many people have that kind of cash laying around.
Yeah.
So 2 megawatts, we did, again, all equity. We didn't have a customer, we wouldn't have been able to finance it. And so the next step up, we had to do something that was big enough that would attract people, but small enough that we could kind of cover the cost on our own without any external financing source.
Okay.
So we come up with a 16 megawatt net, 20 megawatt gross building.
Right.
So 16
megawatt net means that's the IT load. 20 megawatt is the total power going in.
Yeah, which includes kind of, all of the auxiliary power required, cooling and things like that. So, so again, if we just use the round numbers, and it wasn't exactly this 10 is just an easy number, you think about $160 million of total capital. And again, our view is we're not going to finance any of this. We don't have a customer yet, but we want to be able to show to the market that we can do this. And the best way to convince someone that you can actually get it done is to go get it done, in my mind.
Yeah, right.
And so we started building this 16 megawatt building. Again, we still don't have a customer either on the 2 megawatt, and we're spending money here on the 16 megawatts, right? And so it's this balance of what's big enough that you can get interest from real customers, but what's not so big where, we don't have enough money to do it.
Right.
And so this is,
but it's still a big risk, because 160 million, I'm sure. $160
million is still real money.
Still real money for you at that time.
Yeah,
right?
Still real money. And that's where now we started to kind of get traction with folks, because they could come in and they see, okay, great, you do this 2 megawatt building. We understand that it was a pilot. We understand that it was an existing building. We can see what you did here. And then we can now see what you're doing here on the 16 megawatt building, right? We see the designs. We see you've already started the work. You're putting up the steel. And everyone has tweaks, right? I mean, everyone kind of comes in and says, I like all this stuff, but there are these 5, 10, 15 things that I want you to tweak. And that's what we do. And we kind of work with them. But it gave people a lot of comfort. Again, if you kind of, we're power people, as you said, we build power plants, we run power plants, we become Bitcoin mining people. And now you're going to some of the largest companies in the world and saying, hey, trust us to build critical infrastructure for you to run your hardware that's 3, 4, 5 times more valuable than the data center we're even giving you, right? So if we're spending billions, they're spending multiples of that in the hardware they're going to use to populate those buildings. So again, being able to convince those types of folks that we know what we're doing and we have our stuff together, to me, the only way to do that was to just show it.
Yeah.
Just go do it.
Right.
And so that's where that CB1, which is that 16 megawatt building, comes in. And that's where we now start to gain traction, right? People want to come and see what we're doing so they can kick the tires, so they can come up with their own view on whether we have what it takes or not.
Yep.
And fortunately, as people would come in, they'd say, all right, we see what you're doing. Do we have some tweaks? Of course, like everyone's got something they want slightly different, but there's more than enough there. And the one thing that I would do when we would bring people to site, at this point we got 2 megawatts online. We got a few hundred megawatts, 250 megawatts of Bitcoin mining that we're running, is I would take them by the substation. And I would tell them, I'd say, you hear that buzzing sound?
Yeah.
That's hundreds of megawatts of power that's flowing into the site at this moment.
Right.
You don't have to worry about whether the power's there or not. It's there, right?
And we're power guys.
And we're power guys. That's what we do. So now all you have to really evaluate is do you believe that we can put together a design, will give the proper operating environment for your hardware, and can we do that on a timeline that works and kind of to specifications that you want? Yes or no. You believe it or you don't. And so that's what CB1 became kind of a critical part of our ability to convince them that, hey, we could do it.
So you proved it with 2 megawatt, you demonstrated it with 16 megawatts.
And so the first deal we sold is we sold Wolf Den, which is the pilot project, CB1, which is 16 megawatts, and then CB2. And then we said, hey, so if we get a customer, we want to...
These are the different halls, CB1, CB2.
Yeah, these are different buildings. These are different buildings.
Yeah.
So Colo Building 1, Colo Building 2.
Okay.
Then we said, okay, if we can find a customer that we can actually now finance, right? Usually you finance anywhere from 75 to 85% of the cost through debt.
Okay.
But lenders will only give you money.
So you self-funded the 16 megawatts.
Yeah.
Now you're going to CB2.
With CB2.
Yep.
And so this is now a 42 megawatt net building.
Right.
So let's call it 400 million and change for the total construction cost. And that became what we thought was going to be our standard block. It's like big enough where people care about it, but not so big that, there's only a few people that could want it. And so we had a customer, Core 42, come in and say, okay, we'll take down the pilot project, we'll take down CB1, 16 megawatts, and we'll take down CB2, 42 megawatts. We signed that deal in December.
And I'm sure that was part of your business plan, is one customer would walk in and buy up all of that.
Yeah, well, that's, what's interesting, right, is the scale of what we thought was possible. I think we have continually underestimated.
Yeah.
So when we were doing the 16 megawatt, we thought these 15 to 20 megawatt data halls would be kind of a good size. We were quickly learned that, okay, hey, kind of 50 megawatts is probably, more in line with what people want. And that's why we did kind of a 50 megawatt building. So we signed that in December of 2024, right? So kind of in 22, we started saying, hey, we're going to start to play in this space. We spent some time figuring out how to design, engineer, understand who are the players, for the pilot project. And we started building, CB1 in late 23, early 24, and kind of, culminating with signing a customer, right, for 60 megawatts of critical IT capacity in December of 2024.
And then once you have a customer sign, you're off and running on financing.
Yeah, and then because now you have a contract, right? So now you can go to lenders and say, hey, we got a contract, and there's a counterparty, a high quality counterparty that's willing to pay us for 10 or 15 years. You should finance us. And that's where we started that process. And so we thought, again, at this time last year, or in March or April last year, we'd started the financing process. We signed the deal in December of 24.
It was March or April 2025.
Yeah, March. So we started the financing process, and we were then envisioning that our next building would be another 50 megawatt building. So kind of Colo Building 3, CB3 at the site is another 50 megawatt building. And so we're financing that, and we're having discussions with counterparties on that next 50 megawatt building, because we think that's like the next, bite size. And we pretty quickly learned that people were very interested in CB3, but they were interested in pretty much anything we had that we could deliver at the site as well. And so a discussion around a 42 megawatt net building in CB3 ended up, translating into a 370 megawatt deal we signed with FluidStack and Google, because they said, okay, great, you have the power, we know it's here, We see what you all are doing with respect to construction and development. We're on board.
Okay.
Tell us
So
all
now,
you got.
so now you've got a new problem, right? So you've now signed all these customers, and they're saying, "I need it as fast as you can possibly get it to me." Right.
Yeah.
And so this all happened in the course of a couple of years, basically.
I mean, yeah, we started.
So,
I mean, we
so
signed.
talk about how do you guys move so fast, right? Because
So-
we were walking around the
Yeah.
site. You started building a building January 1st. It's now May. You're going to be live
July.
July. Okay, so that's an incredible amount of speed. So I want to talk about a little bit. What'd you do to animate the ecosystem? How did what creative ways did you approach it?
So I think there's a
move that
couple
fast?
things. So there's a couple things. One is there's a lot of money that's required, and if you have the money, you can buy the equipment that you need, and you can pay folks that you need to do the work.
Yeah.
And if you don't have the money, that's not happening. When we signed a deal with Fluid Stacking as our tenant in August of 2025 for 3 different buildings, 2 168 megawatt buildings each, and a 42 megawatt building. When we signed that deal in August of 2025, we had just committed ourselves to spend $3.5 billion at this site. And we probably only had a couple $100 million of it.
Yeah.
Google knew that, FluidStack knew that, we knew that, right? It wasn't a secret. But the schedules that we had predicated that we would be able to get every single dollar we needed relatively quickly. Because if it took us 6 months to get all the money together, our schedules we would not be able to meet our schedules. Right. Because then we can't buy equipment, you can't start to bring people in, you can't start to get. So within 60 days of when we signed that deal, we had every single dollar required to fully construct all of that capacity. And so that's a coordination amongst finance. You know, I think we have one of the best CFOs in the space. So he was able to take the contract and work with Google on creating a credit backstop structure, which our peers kind of reused, had the same exact structure, which is great. I mean, they saw, that we'd done something good and they reused it themselves. So that kind of unlocked the ability for capital to move into the project quickly.
Yeah.
Right? Like I said, within 60 days, we had every single dollar that we needed to build all those buildings. So that's one, is just kind of, again, an understanding of how capital flows and how can we get capital quickly, because that can't be a constraint in any way in terms of time. And then second is, how do you bring all of the various scopes and trades together to be able to get it done?
Yeah.
And so that's where, again, I think here, and this goes back to Beowulf and building power plants, and then the TeraWulf and building Bitcoin mining data centers, is that we've been in construction at the site since 2021.
Yep.
Different scale, yes, but we've been in construction, right? So civil contractors, electrical contractors, mechanical contractors, they'd already been coming to our site. And so we weren't starting from zero in terms of now getting labor to come to site. We already had that flow coming.
You had the relationships.
We had the relationships. We knew who the subcontractors were. We knew who we liked. There's some folks that are working at the site today that have been working here for 4 years straight. They're not our employees. They're employees of our.
You mind sharing how many employees are working here right now, including the contractors as well as direct?
So the construction, there's about 1,600 construction folks at the site.
Okay, so we've taken an old generation plant that was getting mothballed, that nobody was sure was going to happen, and now it's actively employing 1,600 contractors.
Yeah. And we'll have kind of, when we're up to full capacity, we'll have about 125 folks on our staff at the site here. And our tenants will probably have anywhere from 180 to 220 people that they employ to kind of maximize the value of the compute they have here, right? So we'll probably have over 300 employees at the site here once all of the capacity is up and online. So you got to figure out how to make sure the money comes in quick, right? So that's not a constraint or bottleneck in timelines. You got to understand how to get all the equipment here.
Yep.
And so what we do with all of our vendors and suppliers is try to give them kind of a 12 to 18 month rolling forecast. Hey, this is what we think we're going to need. So they can be in our ear and saying, hey, if that's what you're really going to do, you should be doing stuff today or yesterday, or, you could do it next month or 2 months from now. But they also have a sense of what we're looking for. And so we've been able to kind of be ahead, I would say, we're in a reasonable place on our equipment procurement. And then it's bringing a bunch of people to the site to put it all together.
Yeah.
And that's where the coordination is critical. And given that our DNA has been development, right? We're developers by nature.
Yeah.
I think we come at problems in solving in terms of like, how do we figure out how to make it work? And we're generally unconstrained by, well, this is how it's supposed to be done.
Right.
And if you think about what we're building here today, what we're building hasn't been built for the last 5 or 10 years.
Nope.
Right.
New.
It's new.
Different. Yeah.
So no one's got a way that has been done like that for the last 10 years. That just doesn't exist. And so I think generally we come at it in an unconstrained way. And on top of that, I think generally where the market is there's no real precedent.
Yeah.
And so it allows us to be creative and nimble and work with partners and counterparties who have that same approach.
Yeah.
We're thinking about ways to kind of bring this capacity online as efficiently and safely as possible. And so what we have going on here at Lake Mariner, I would say everyone from our customer, our tenants,
Yeah.
they've got the same mindset. They're aligned with us. They want that compute up. What decisions can they make to ensure that they are facilitating that and not kind of extending that? I mean, if you think about where data centers came from, I would say that a data center 10 years ago probably took 24 months to build.
Yeah.
And it was only 40 megawatts.
Well, yeah, and my understanding too is that you'll make design, trade-offs in order to optimize around what equipment suppliers like us can provide. So
Yeah,
you'll
yeah.
call us and say, well, what do you have available? And then that might drive some of your design choices.
Right, and
It's
then
a
we-
different dynamic.
Yeah, and which could have a subsequent kind of tweak on our customer as well. And so we'll call the customer and say, hey, this is what we had scoped out, but this is a slightly different scope. This is what it means. These are the trade-offs. And
Yeah.
the word you use, trade-offs, I think is critical. I tell my kids this all the time. There's usually not a perfect decision on stuff. There's trade-offs. You may get something, but you may give up something, right?
Right.
And so especially given the speed at which we're working here, we're making those decisions every single day, every single week. And like I said, from the tenant to us, to our suppliers, to the subcontractors we're working with, we're all really aligned in thinking about, okay, hey, the end goal is getting that compute up as efficiently and safely as possible. And there's usually more than one way to accomplish some of the particulars of that, right? So there could be specific line items that, as you said, something may be only available in 9 months, but if we have something available in 2 months, but it requires some subsequent changes, should we do that? And again, more often than not, the decision will come to is, yeah, it's worth it. Let's go figure it out. But that in of itself creates stress in the system as well, right? Whatever plan you had is now revised.
Yeah.
And that has an impact on both labor in terms of what people are doing, when they're doing it, how they're doing it, and also maybe in terms of capital, right? I mean, and sometimes there's ins and outs, right? Something may be cheaper, something may be more expensive. And then there was likely be an impact on just kind of what it means for the end tenant as well.
Yeah.
And so we have to be very coordinated across the entire chain so that every single decision we're making, our tenant is aware of,
Yeah.
they're comfortable with, and they understand it. And likewise, the folks that we have on site, both the suppliers and the contractors that we have working here also are in tune with that as well.
Yeah, and that's one of the points that is just maybe to put an exclamation point on this is that, throughout your history, you were collaborating with the utility and the community substation, and you just went through collaborating with the equipment provider, your customer, and, so how you animate the AI ecosystem, for lack of a better term, is an important way for you to move as quickly as you have been able to, including financing and with Google and some of the things that you had to get creative in order to move fast.
Yeah, absolutely.
So it's possible to move fast.
It is. I mean, and I think everyone in the space is moving fast, right? I mean, I think everyone recognizes the opportunity. And as I was mentioning earlier, and again, I wasn't in the business 10 years ago. So from what I understand, right, to my understanding, talking to folks that were in the business is that the specificity and the stringentness with respect to some of the scope and design considerations was very firm.
Yeah.
And
That's
even the largest customers in the world today are open to pretty much any idea if it means
they can be faster.
they could be faster.
So in the last couple of minutes here, first of all, one of the things I want to acknowledge, and one of your guys, when we were looking at the site today, super proud about the labor in Buffalo, and that these guys were out in January. And if anybody's been in Buffalo in January, the weather's not great, and you had a labor force that was willing to start working in that weather to start laying steel for the building that we walked through today. So I think it's important to acknowledge that's part of the ecosystem. You touched on it, but I think it's important to emphasize. So
I would say that the local communities are critical to the success of any one of these projects.
Yeah, it's fantastic.
They have to be on board, they have to be bought in, and they have to want it to succeed. And I would say the folks at our site here, this to them is personal.
Yeah.
Right. The idea that we were able to take a former coal-fired power plant that used to employ 300 people, who all kind of over time, those jobs went away.
Yeah.
And as I said earlier, now we're going to be ramping back to over 300 people that are employed at the site. while we brought 1,600 folks for construction as well, they're proud of what they're doing here as well, right? They're literally taking a site that was kind of that was an old, economy coal-fired power plant, and literally kind of through their hard work, through their dedication, transitioning that to kind of what is the economy of the future, and they're a critical part of that. And so I would say that the speed and efficiency that we have does not happen without folks like that on the ground here at the site. And it's also the local communities that support us. So it's not just the folks that show up here, but it's also the town and the county that we work within, right? They have also been incredible partners in helping us ensure that we can meet these aggressive schedules. I mean, you can imagine coming to them with a building design for 215 megawatt gross, 168 megawatt net building. They've never seen anything like it. Not many people have.
Nope.
And so when we're like, hey, we want you to review this and get back to us in like 10 days, that's not an easy task, right, for anybody. And so to their credit, I would say that they have been as focused as we have been in ensuring that they are, again, partners in facilitating these accomplishments that we have. And so again, I'd say it's for sure the people at the site, but I would say it's even the people that are not at this site that are part of the local communities that have been a critical part of the success we've had.
Yeah, it's really a fantastic story about how data centers having a real positive impact on the local community, taking a site that was likely to be mothballed, brownfield, all those types of words, and turning it into something really productive. So, and as Schneider, we're super proud, right, to be part of that AI ecosystem as well. So thanks very much for sharing your story and taking the time.
Pleasure, Kevin. Thank you so much.
Thank you.